3.
Hello, Puan. My name is Marishal and my McCrew number is 23DEM22F1004.
Hey ma'am, my name is Homsundarisa, son of Maria. My metric number is F1003.
Hello ma'am, my name is Nagan and my metric number is F102.
We are going to do EOC2.
Which is self-excited DC motor. The definition of self-excited DC motor. The DC motor is an electrical machine that converts energy into mechanical energy.
First, series self-excited DC motor. Definition of series self-excited DC motor. The series self-excited DC motor is a type of direct current that's called DC motor that operates based on the principle of electromagnetic induction. In this motor configuration, the series self-excited DC motor circuit relies on the between the hand field winding to generate the necessary magnetic field for motor operation. The motor speed and torque categories can be adjustable by controlling the field control, typically achieved by varying the field resistance. This is the diagram of the electric motor diagram of series.
So, how to derive equations for series self-excited DC motor? So first is motor components. The series self-excited DC motor consists of a rotor armature and a stator field winding. The armature winding is in the series with the field winding and the external circuit. The motor generates torque by the interaction between the magnetic field produced by the field winding and the current flowing through the armature winding. So second is electrical equations. So Kirchhoff voltage law, which is KYL, for the electrical circuit, V is equals to IA RA plus E, where V is the applied voltage, IA is the armature current, RA is the armature resistance, and E is the back EMF generated in the armature. So third, mechanical equations. Torque equation. The torque developed by the motor is proportional to the armature current and is given by T is equals to KT. IA, where KT is the torque constant of the motor. Next, system equations. Equating electrical power input to mechanical power output, which is Mach V times IA is equals to Pmac. Substituting expressions for the electrical power, V times IA, and mechanical power, TW, V IA is equals to KT.
Second is shunt self-excited DC motor. Definition of shunt self-excited DC motor. A shunt self-excited DC motor is a type of DC motor where the field winding is connected in parallel shunt with the armature winding. In this configuration, the field winding is supplied with a portion of the total armature current, allowing it to generate a magnetic field independently to the armature current. The term of self-excited indicates that the motor generates its own magnetic field without the needs of the external field source. And here is the electric motor diagram of the self-excited of the DC motor. And the self-excited DC motor circuit relies on the integration between the armature and field winding to generate the necessary magnetic field for the motor operation. The motor speed and the torque characteristic can be adjusted by controlling the field current, typically achieved by varying the field resistance.
How to derive equation for shunt self-excited DC motor? First, motor component. The shunt self-excited DC motor also consists of a rotor, ammeter, and sister field winding. However, the field winding is connected in parallel shunt with ammeter not in series. Second, electrical equation. Kirchhoff voltage law (KVL) for the electrical circuit, V equals to IA RA plus E plus IF RF, where V is the applied voltage, LA is the emitted current, RA is the emitted resistance, E is the back EMF generated in EMF. Third, mechanical equation. Torque equation. Similar to series motor, the torque developed by the motor is 2 emitted circuit T equals to KT times IA. System equation. Equating electric power input to mechanical power output, Mach V IA equals to P Mach specification expressed for the electrical power and mechanical power. Final equation. This equation represents the relationship between the applied voltage, angular velocity, current, field current, and emergent resistance, field winding resistance, and the motor resistance K and KT.
Compound self-excited DC motor. Definition of compound self-excited DC motor. Compound self-excited DC motors offer a balance of performance characteristics suitable for a wide range of industrial and commercial applications. The ability to provide high starting torque, stable speed regulation, and flexibility in design makes them versatile and reliable solutions for various motor driven systems. So, the compound self-excited DC motor circuit combines the features of series and shunt motors to achieve a balance of high starting torque and stable speed regulation. The interaction between the series and shunt field windings allow for versatile performance suitable for a wide range of industrial and commercial applications. So this is the electrical motor diagram of compound self-excited DC motor.
How to derive equation for the compound self-excited DC motor? First is cumulative compound motor. In a cumulative compound motor, the series and the shunt field windings aid each other. And second is the electrical equation. Kirchhoff voltage law KVL for the electrical circuit. V equals to I RA plus E plus IF RF, where V is the applied voltage, IA is the armature current, RA is the armature resistance, E is the back of EMF generated in the armature. If the field current and the RF is the field winding resistance, the back EMF E is the proportional to the angular velocity W of the motor. E equals to K times W. For the third is mechanical equation, torque equation. The torque developed by the motor is proportional to the armature current. T equals to KT times IA. And for the fourth is system equation, equating electrical power input to the mechanical power output. Match V times IA equals to P match, substituting expression for electrical power V times IA and mechanical power P times W. V times IA equals to KT times IA times W. And for the 5 is final equation. This equation represents the relationship between the applied voltage, angular velocity, armature current, field current, armature resistance, field winding resistance, and the motor constants K and KT. And for the last is fixed differential compound motor. In a differential compound motor, the series and the shunt field winding oppose each other. The total field flux in the difference between the flux produced by the series winding and the shunt winding.